So in this question, we're given a triangular prism. So that's a solid block of glass. And we're given the dimensions x and L. We're told that the cross-section is an equilateral triangle. So we now know that this triangle is equilateral. Equilateral means that all the sides are equal. And that means all the angles are equal. So we know that this angle is 60 degrees, 60, and 60. So they add up to 180. And we're given that the total volume of the prism is 2000. And they're asking us to derive an expression for L in terms of x. So let's start by looking at what's the volume of a prism. So the volume of a prism or a cylinder is the cross-sectional area multiplied by the length. So volume is the area times the length. So if we find this area here, you multiply by the length, L, that should give you the volume. So the cross-sectional area looks like it's a triangle, and these sides are equal. So we can say that's x and 60. Now remember, the area of a triangle is half AB sine theta. And in this case, because it's an equilateral triangle, A and B are both going to be x. So it's half x times sine 60. So that's half x squared, and sine 60 is root 3 over 2. So that's root 3 x squared over 4. And that area we can put into there. So we now have root 3 x squared over 4 times L. And we know that that volume is equal to 2000. So we can say root 3 times x squared over L. So over 4 times L equals 2000. And we need to rearrange that in order to find L. Okay, so to rearrange, you would multiply both sides by 4 and divide both sides by root 3x squared. And we would do that so that this 4 would cancel with that 4, and these would cancel, and we're left with L equals. So L equals, if you multiply 2000 times 4, that's 8000. And then x squared root 3, which is the same as the expression they asked us to find. So that's your first part. The second part of the question says hence, and hence means using what you've just found. So we're using this information to find the surface area of the prism. Okay, so let's look at the prism again. The prism consists of we're not looking at the volume now, we're looking at the outside surface area. So if you look at it, it consists of two triangles and three rectangles, right? So the surface area is a triangle at the front, a triangle at the back, and there are three rectangles. That's the first rectangle, that's the second rectangle, and that's the third rectangle. So the surface area is a triangle plus a triangle plus a rectangle and a rectangle and a rectangle. And if you see that the three rectangles have the same dimensions and the triangle has the same dimensions. So really it's just two triangles and three rectangles. Now the triangle, the area, we've already agreed that we can find that by saying it's root 3 x squared over 4. And there are two of them, so it'll be 2 times that. Where did we find that? We said it up here. We said the area of a triangle is root 3 x squared over 4. So that's the front triangle and the back triangle. Now for the rectangles, the area of a rectangle is the length times the width. And this is x, this side is x, and this side is L. So really we're multiplying L times x to find this area. So the answer for the area is simply plus 3 times L times x. Now that would be our final answer, except they want us to give the answer in terms of x without L. And they said hence, so we're expected to use this expression here. So what we need to do is replace L here with the value that they gave us previously, or that we found previously. So we can say this is equal to root 3 x squared over 2 plus 3 times, let's just multiply 3 times, no, I'll leave it like this. So 3 times 8,000 divided by x squared root 3. Okay, and again, we don't want to leave it like that because they are asking us to show that it looks like that. So let's try to rationalize the denominator. So 3 divided by root 3 is root 3, and then we can take root 3 over 2 as a common factor. So you've got root 3 over 2 into x squared, and if you divide that by 2, no, you multiply that by 2 because you've got that, and that x, I forgot to multiply by x. So let's move that and put an x. So this x is this x, this 3 is this 3, and this is L. So that will give us x squared plus 16,000 divided by x. And that's the same as the expression they gave us. So that's the answer to part B. The question then goes on to ask for the exact value of x at the stationary point. Now, stationary point, they haven't made that very clear. What they should have said is when A is minimum or maximum. So that's what it means. The stationary point is when A is a minimum or maximum. And for us, that means when the derivative of a, dA by dx, is equal to 0. So we need to differentiate this. So let's rewrite a. Let's say a equals root 3 x squared over 2 plus 8,000 root 3 x to the minus 1. So I brought this up, and now that's my a. This is the same as that. Now we want to differentiate this, dA by dx. So that's just root 3x minus 8,000 root 3 x to the minus 2. And because it's a stationary point, we can say that that's equal to 0. So now the question is, how do we solve this? It looks almost like a quadratic, but it isn't because we've got a negative power. So if you rewrite the negative power as x to the 2 in the denominator, it becomes a little bit clearer what we need to do. So you need to get rid of the x squared in the denominator in order to be able to solve for x. So what you could do is multiply throughout by x squared. So you multiply the left side by x squared, multiply the right side by x squared. So you'll get root 3 x cubed minus 8,000 root 3 equals 0. So that will cancel with that, and that's just going to give you 0. And x squared times x gives you x cubed. So it looks like a cubic, but because there's only one term containing x, it's not too bad. So if you move this to the other side, that'll give you that. And if you divide both sides by root 3, you get that. So x will be the cube root of 8,000. And I think that's just 20. Yeah, 20. So that's the exact value of x when dA by dx equals 0. So that's the answer for this question. The question then goes on to ask for the value of L. Now, what's the relationship between L and x? We found that up here, and even if we didn't find it, we already know this from the question. They gave us this expression, so even if you were unable to find it, you can use this relationship. Okay, and because they're saying the corresponding, that means corresponding to the value of x as 20. So you can simply calculate it like that. So it's 20 squared root 3. And because they ask for the exact value, don't put it in your calculator. Just leave it, but make sure you rationalize the denominator. So you'd multiply by root 3 over root 3. And 20 squared is 400. And 8,000 divided by 400 is 20. So I think that just gives you 20 root 3 over 3 centimeters squared. centimeters, sorry, because we're finding the length. So 8,000 divided by 400 is 20. Root 3 multiplied by root 3 is 3. So that's your answer to this part. That's just 1 mark. It then says find the exact value of the minimum area. So that means the area when x equals 20. And again, we're given this expression, so we're allowed to use it. So you go back and simply replace x here and here with 20. So you've got 20 here and 20 there. So it's root 3 over 2. So that's root 3 over 2 times 800 plus 400. So that'll give you 1200 divided by 2 is 600. So it's 600 root 3. And again, don't put that in your calculator because they want the exact value. So the surd has to remain. And the unit will be centimeter squared. The question then goes on to say, show that the value of A that you just found is a minimum. Well, what they mean is show that it's not a maximum. And to show that your turning point or your stationary point is a minimum, you need to show that the second derivative, d squared a over dx squared, we need to show that it's positive. So let's find the second derivative. All right. The first derivative we found was here. So that was our first derivative. We need to differentiate that again. So that was my first derivative. So our second derivative should follow from that. D squared a over dx squared is root 3 plus 16000 root 3 x to the minus 3. And all you need to do is substitute 20 in there and show that what you get is positive. So we're going to say d squared a over dx squared when x equals 20 equals root 3 plus 16000 root 3 divided by 20 cubed. And that, well, this is positive and this is positive. Therefore, when you add them, you're going to get something which is positive. And you can then say, therefore, A is a minimum. So the condition for having a minimum is that the second derivative is positive. And I think that's the end of this question. So quite a lot of work. The good news about this question is that even if you don't know how to do this, the first part, and if you don't know how to do this, you're still able to answer part C, D, etc., because you can use this information. So you can just differentiate this and then substitute that. So you don't need to get A and B right. in order to get the remaining marks.